Hello everyone, in this video we are going to present our Integrative project. We call it Packing Donuts Machine, and our team is conformed by me, Alan Agustín Orozco, José Nicolás Sánchez Duarte, José Hugo Alamillo Chávez, and Ángel Rosales Reyes.
Machine designing. Okay, for this part we have the design of our project and its the different parts. Well, I will start by explaining the process. In this part, all the process begin or start. We put the boxes in this contain 15 boxes fit, and this can be gravity. Then the van start to work at this station. In this part, the box is filling with the donuts, and finally we close the boxes with this tab in this part, like this. Okay. This is the place where the different sensors are found in our project. We have 4 sensors. This 2 is for the boxes and this for the donuts. And these are the places where the motors and the control panel are located. These 2 motors is for the bands of donuts, and this one is for the boxes. Our panel sensor is very simple. It has turn on and off, the reset button, and the emergency button. Well, pass it with my partner Angel to explain to controls and actors. And to finish, we go through the cost and manufacturing. Here we put a table with the materials, price, and the place where we find them cheaper. And we put another manufacturing table with the total price and the final cost of everything. And that's all. Thank you.
Hi, my name is Ángel Fernando Rosales Reyes. This is the session 4 on the Integrative Donuts Packing Machine. We want to see the controller, the sensor and actuators, the security elements, and the consumption of kilowatts. The controller is Arduino Mega 2560 with a market cost at 100 to 299 Mexican pesos. We decided to use this type of controller because it's easy to connect. It have a lot of pins, outputs, and inputs. In the video, I put 2 links. The first one is the official page of Arduino to learn the program, and the second is a video to learn the basics of Arduino. The specification of Arduino Mega 2560 is have more capacity, 266 kilowatts, easy connection with USB cable, speed of 16 MHz, operating voltage and 5 volts during current. Current consumption is 50 milliamperes. The input voltage is 7 to 12 volts during current, and the input voltage limit is 6 to 20 volts during current. We have sensors. We use the optical sensors. It's a Monarch remote. The maximum detection rate is 3 feet. The operating voltage is 24 volts, and the worker current is 20 milliamperes. The capacity sensor, the maximum detection rate is 0.2 to 0.4 feet. The operating voltage is 24 volts. and the working current is 20 milliamperes. This is the piston. It's a double acting piston, 40 to 300 millimeters. This element is activated with electrovalve. We use this electrovalve pneumatics, 5 2 position. The operating voltage is 24 volts, the direct current, and the working current is 120 milliamperes. We use relays. The operating voltage is 5 volts, the direct current, and the working current is 50 to 20 milliamperes. We use gear motors. The operating voltage is 24 volts, and maximum current consumed is 8.5 amperes. The power is 150 watts. The velocity is 18 to 240 RPM, and the torque is 4.8 kilograms per centimeter. This is kilowatts on consumption. We have the elements, the quantity, the voltage, and direct current, the amperes, and power. We use one Arduino, 2 optical sensors, 2 capacitive sensors, 2 double acting pistons, 2 electrovalves, 2 relays, and 4 gear motors. The yearly use of machine is 8 hours. Days per week is 6. The total hours per month is 192 hours. The power consumption is 608.30 watts, and the power consumption total in work hours is 116.7 kilowatts. In the security elements, the operator of the machine will be at this place of work at the moment the line is turned on. The production line has a emergency button on the control panel, and 2 more, the green for to start the process and the red to stop. So, in the safety factor, it's important to know the weight used per cycle and the capacity of the machine, so that the operator is not in danger when he's work. To know these values of this date, we use this table. The product, the weight, the quantity per cycle, and the total weight. We have the donuts. The weight per donut is 100 grams. The quantity per cycle is 60 donuts, and the total weight is 6 kilograms in the donuts. In the box, the weight per box is 70 grams. The quantity per cycle is 10 bucks, and the total weight is 0.7 kilograms in the box. In the total weight per cycle is 6.7 kilograms. So in the structural material, we use the tubular profile steel, is 18 gauge. So with the design we made, the machine can support more than 10 kilograms per cycle. So we have a range for the capacity for the operator safety. In the electric system, in the Arduino connection, electrovalves, and sensors, the total current is 150 milliamperes. So we use the 14 gauge with a conductor diameters and millimeters is 0.110. In the motors, the total current is 25 amperes. So we use the 7 gauge. The conductor diameters millimeters is 3.665. And the electrical connection or common use, we use the 14 gauge with a conduction diameters in millimeters is 1.628. Well, to know these values, we use the gauge tablet. You can use it to choose the correct cable for the connection depending on the total amperage in each section. For example, in the motors, the total current is 25 amperes. So when you higher amperage, it can be 30. So in this day, the gauge is 7, with a conductor diameter is 3.665. So, well, in conclusion, I hope this information about the components will be very helpful for future projects in the mechatronics. See you.
Hi, my name is NICOLAS SANCHEZ, and I will explain you the manufacturing process of our packing donut machine. Mechanical process. In this part, we have to make the deposit for the boxes that are the donut packages. We have the measurements, and then for this process we need 18 gauge stainless steel sheet of 90 centimeters wide by 3 meters of long, cause it's the most appropriate to not waste material. We decide to use this material because it is in contact with the donuts and it could spoil the donuts. We need a bending machine like this one. I think that we need to pay for this operation in a blacksmith shop. Also, it's necessary to use a grinding with green and grinding disc to remove the board and give it a better aesthetics. 3 bends of 90 degrees will be applied to the sheet. Also, we have to make these supports of the conveyor belts with the same sheet. We have to use these tools to put the supports in the conveyor belts. CNC machining and code. We need to make these pieces in CNC machine. This is a part of the code. It's a very simple code. It's necessary to use a quarter diameter half in and the quarter down a millimeter per pass. This is a simple simulation of the operation in CNC machine. Let's see. Welding operation. It's very important that we follow the security measures to do a good project. We will to use manual arc welding with coiled electrode, 1 in square tubular profile 18 gauge quarter steel plate, 1.5 kg of electrode 1613. After the welding process, it's necessary to use a grinding to give it a better aesthetic. Operations with other materials. We search the different types of the conveyor belts and we find the best to our project cause it needs 1 conveyor belt for fending application for the donut packages, and it's necessary to use 2 conveyor belts on packaged food for the donuts. Detail and painting. We have to clean the surface that we need to paint. This type of paint is the best cause protects the material and give it a better aesthetics. It's important that we need to use a mask not to smell the paint and thinner. Cutting materials. We need to use a machine to cut the profiles and the disc of 12 in. That is about the mechanical process.
Hello everyone, my name is Alan Agustin Orozco, and I am going to talk about the programming part and the circuit about our project. This is our project. Okay, I am going to explain you this part. This part are the optical sensors. And these sensors are going to be detecting the boxes that are going to pack the donuts. This sensor, the first sensor, is going to be in here, in this part detecting boxes. If the first sensor detects boxes, this conveyor belt will be turned on until a box arrives to the second sensor that is going to be in this part. When this second optical sensor detects a box, this conveyor belt will be turned off for a second to 6 donuts are packaged. These are the capacitive sensors. These sensors are going to be in this part of the project, in here and here. Okay, how these sensors work is simple. They detect something and send a signal through a pin of Arduino. In this case, is the pin 7 and the pin 8. The code and the sensors do everything. The capacitive sensors will be detecting if there are donuts. These both conveyor belt are gonna be working all the time. When the donuts arrive and the sensors detect the donuts, both conveyor belts are going to stop for a while. When the donuts arrive in this part where these sensors can detect them, two relays connected to Arduino are going to make work two valves. I can show you in here. This relay connected to Arduino and these two bulbs. These two bulbs will be connected into these two double effects that are going to pack the donuts. This conveyor will be working until the sensor detects donuts again. One important thing is how the three conveyor belts work. I can show you the circuit of the motors that are right here. These are two H bridges, which one will receive the signal from Arduino, and they will make work the motors in the right moment. I am going to explain you the programming part. Let's start. I am declaring two Boolean variables that are the sensor of the donuts. Here, defining the pins of connected the H bridge. I declare the pin bulbs. Here I'm declaring the H bridges. The output pins for the relays to control the bulbs and the cylinders of the double effect. Here in this part, the optical sensor in here is detecting the boxes. If this sensor detects something, this conveyor belt is going to turn on, and the second optical sensors that is here, if this sensor detects a box to pack the donuts, the conveyor belt will stop. If this sensor doesn't detect a box, this conveyor belt will work. This capacitive sensor stops the conveyor belt to pack the strawberry donuts. That these capacitive sensors, two are gonna be in here, like I said. If the sensor detects a strawberry donut, the conveyor belt stops. If the sensor doesn't detect something, the conveyor belt will be working. This capacitive sensor stops the conveyor belt to pack the chocolate donuts. This is the same thing that this, but this is for the strawberry donuts, and this is for the chocolate donuts. If the sensor detects a chocolate donut, the conveyor belt will be turned off. Sorry. If the sensor doesn't detect something, the conveyor belt will be turned on. In this part, I establish a counter to tell 3 times for the 3 strawberry donuts and the 3 chocolate donuts. And next, this part stop the conveyor belt to pack the strawberry donuts. If the sensor detects something, if there is a donut right here, that's why I established 2 Boolean variables for this part. If there is a donut, the conveyor belt stops. If there isn't a donut, the conveyor belt will work. This This stops the conveyor belt to patch the chocolate donuts, and if the sensor detects something, if there is a donut, the conveyor belt will stop. If there isn't a donut, the conveyor belt will be working. This is all for my part. I hope it liked you. Thank you very much for your attention.